Alright, so we're going to take a look at problems 1 through 4, but to be honest with you, I'm going to skip number 1 because you really should be able to do this alright on your own. Alright, so, okay, whatever, we'll do it. So, from 12 to 2, that's a total of 2 hours, which is 120 minutes. Alright, so we need to add some extra minutes here. Alright, so how far away from the extra third hour are we? Well, let's see. Well, we're, what? If we add, what would we add? 43, so here we go. That'd be 9, right? So we're 51 minutes away from getting full hour, so that's 171 minutes. Alright, great. Alright, so number 2. The solutions to the equation are m and n. What is the value of n? M minus 1 times n minus 1. Express your answer as a common fraction. Alright, so this is what we've been working in class. We need to find the x-intercepts, and because the x-intercepts are the solution to a quadratic problem, and to do that we have got to factor. Alright, so this is a little more challenging factoring than we're used to because we have this value right here, this quadratic coefficient of 2. So if I'm looking at a binomial pair, because that's the only way I can really deal with this, because 12 and 2, neither of them are perfect squares, so I don't have a difference of squares or a square binomial, and there's no common monomial, so I've got to do this. All right, so we know that we're going to have a 2x and an x, because 2x times x is 2x squared. And I know I'm going to have a positive and negative, and we need to get 12, right? So what numbers multiplied together equal 12? Well, there are a lot, unfortunately. There's 1 and 12, there's 2 and 6, there's 3 and 4, and that's about it, right? So here's the catch, and this is why this is a little bit different. None of these factor pairs is going to add up to 5, and that's okay, because we have this 2 here, so we're going to have to multiply this times this value here for our linear term, as well as this times this for our linear term. All right. So, and we want a positive, so we can pretty well establish that this is probably going to be positive, but not necessarily that's going to be negative. All right, so 2 times 4 is 8, 8 minus 3 is 5, so the 2 has to be multiplied by the 4, because 2 times 4, that's going to give us 8x. That makes this 3, because negative 3 times 4 is negative 12. Negative 3 times x is negative 3x, so that will give us our positive 5x for our linear term. So we've successfully factored that. Great. Now it's time to find the solutions. To find the solutions, we separate it into 2 problems, set each one equal to 0. So in this case, x is going to be equal to negative 4. Over here, we're going to add 3, so we get 3 is equal to 2x divided by 2 divided by 2, and we get x is equal to 1 1/2 or 1.5. All right, and I put 1.5 because we're going to have to deal with this right here. All right, so m and n are 1.5 and negative 4. So here we go. So we have negative 4 minus 1 times 1.5. Oh, you know what? It says expressed as a common fraction, so I'm going to keep this as 3 over 2. Maybe. One more. There we go. So that's 3 over 2 minus 1. Alright, so we get negative 5 times, well, that's just going to be negative 1/2. So then when I multiply that together, oh wait a second, shoot. Alright, that's a negative 4, so that's a positive 1/2 because 3 halves is more than 1. So I multiply that together, I get negative 5 over 2, and that is my answer. And it has to be this answer because it is a common fraction. Sander! Excuse me. Alright, the last 2. The sum of 2 integers is 35, so that means I have, let's say x plus y is equal to 35. I'm just going to say x is the larger one. So x is means equal, so the greater number is 4 less, that's minus 4, than twice the other value. All right, and the question is, what is the greatest number? All right, well, okay, I just plug this in for x. So we have 2y minus 4, that's that, plus y is equal to 35. So that is 3y minus 4 is equal to 35, which means that 3y is equal to 39, y is equal to 13, but that's not our answer, because that's the smaller of the two numbers. So something plus 13 is 35, and that number would be, well, I'm going to subtract it so I don't make a mistake in my head. So we get to 22. 22 plus 13 is 35, so the answer is 22. All right, the last problem, here we go. Ooh, exponents. All right. If the values of 1, 2, 3, and 4 in some order are assigned variables of a, b, c, and d without using any value more than once, what is the greatest possible value? So my first inclination is we want a big exponent, right? So I kind of want to go with 1 plus 2, and that would be to the 3 plus 4 power. So that would be 2 to the 7th. 2 to the 7th is good, but it's not as good as it could be. I mean, 2, 2, 3, 4, 5, 6, 7. 128 seems pretty good. However, I feel like we might be able to do better. So let's try another combination. Okay, so I do know I want that 4 there. So let's switch the 3 and the 4, 3 and the 2. So we're going to go with 1 plus 3, and that is going to be, so then we got the 2 plus 4, alright, so that is 4 to the 6th. Now, wait a second, 4 is just 2 squared, right? So we have 2 squared to the 6th, that's going to be equal to 2 to the 12th. That is way bigger than 2 to the 7th, so I think I got it. I think we got it. All right, so this is 2 to the 7th on our calculator. 8th, 9th, 10th, 11th, and 12th. And so there's our answer, 4096. All right, so there you go. Have a great, great weekend.